What's up, everybody, and welcome to the Hydraulic Engineering Tutorial YouTube channel. Today, we show experiment number 18. To determine the velocity distribution in a given pipeline and obtain the energy and momentum connection factors. Apparatus. 1. A straight pipeline having a graduated scale connected at the section where velocity distribution is to be obtained. 2. A Prandtl-Pitot tube with a differential manometer connected to it inserted in the pipeline at the section where the velocity distribution is to be obtained. 3. A pointer connected to Prandtl-Pitot tube such that it moves along the graduated scale on moving the tube. 4. A regulated water supply. 5th, a discharge measurement unit in the pipeline, venturimeter with manometer. Theory. While deriving Bernoulli's equation, it is assumed that the velocity distribution across a single stream tube is uniform. But if there is an appreciable variation in the velocity distribution, on account of viscous and boundary resistance, correction factors alpha and beta have to be applied to obtain the exact amount of kinetic energy or momentum available at a given cross-section. Kinetic energy correction factor, A. Kinetic energy correction factor is defined as the ratio of the kinetic energy of flow per second, BASD, on actual velocity across a section to the kinetic energy of flow per second based on average velocity across the same section. Momentum correction factor, V. Momentum correction factor is defined as the ratio of momentum of the flow per second based on actual velocity to the momentum of the flow per second based on average velocity across a section. Velocity distribution across a section can be obtained with the help of a pitot tube, which is one of the most accurate devices for velocity measurement. It consists of a glass tube in the form of a 90-degree bend of short length open at both its ends. It is placed in the flow with its bent leg directed upstream so that a stagnation point is created immediately in front of the opening. The kinetic energy at this point gets converted into pressure energy, causing the liquid to rise in the vertical limb to a height equal to the stagnation pressure. Procedure 1. Lower the Prandtl tube until it touches the lower wall of the pipe, and note the pointer reading on the scale G1. Then raise it until it touches the upper wall of the pipe, and note the reading G2. 2. Open the inlet valve fully, keeping the outlet valve closed, and remove air bubbles, if any, from the manometric tube. 3. Open the outlet valve and allow the flow to take place for some time. 5th, measure the discharge Q through the pipeline. Note the manometric readings H1 and H2 and the pointer reading G at different positions of the Prandtl tube along the pipe diameters. The interval between successive paritions of the Prandtl tube must be kept small, i.e., 2 to 5 millimeters. 6. Repeat steps 3 to 5 for different openings of the valve. Precautions. 1. Before taking the reading, check that there is no air bubble in the pitot tube or manometer. 2. The pitot tube should be placed at a sufficient distance from the regulating valve to avoid turbulence. 3. Check that the holes of the pitot tube are not blocked. Don't forget to like this video and subscribe to the channel for more hydraulic engineering content. Thanks for watching, and I'll see you in the next video.